All right, let's talk about the Colorado Plateau, which came to fruition also during the Cenozoic. Again, these aren't necessarily in chronological order. These are just particular events in around the world that are notable for what they created geologically speaking. So we're talking about the Colorado Plateau area. We're talking about this region, kind of between Utah, Colorado, New Mexico, and Arizona. Um, From the Mesozoic, we had Cretaceous age marine sedimentary rocks, indicating that this area was initially below sea. Think back to the Cretaceous interior seaway, Sundance Sea, those sorts of things. So we had Cretaceous sedimentary rocks. But during the Paleogene period, the laramide deformation, we just talked about the laramide orogeny, yielded some anticlines, arches, and basins, and a number of large normal faults in other areas as well. However, deformation was far less intense than elsewhere in the Cordillera along the Rocky Mountains. So in this area where the Colorado Plateau occurred, there was some uplift as a result of the laramide orogeny. Neogene uplift elevated the region from near sea level to the 4,000 to 6,000 foot elevations seen today. For instance, Flagstaff sits on the Colorado Plateau, and that Flagstaff has an elevation of I forget the specifics, but somewhere between 5,000 and 6,000 feet elevation. All right, so that area was at one point again at or actually below sea level, since it was covered with marine sedimentary rocks. Got elevated during this laramide orogeny process. As uplift proceeded, streams stripped away some of the younger overlying rocks and eroded down into the underlying strata. This is how the Grand Canyon kind of got formed. So the Grand Canyon, which is also up on the Colorado Plateau, we had all these layers. We have rivers running across it, and imagine a saw, right? Imagine I have a saw, all right, and I'm sawing, and I'm sawing, and I'm trying to cut down. But at the same time, I'm trying to cut down, through wood. The wood's also getting pushed up. So I'm going to be able to cut through that faster and more effectively because I'm pushing down, and the wood below me is being uplifted. So I'm making it easier for me to cut down into that wood. Well, same with the Grand Canyon, what we now know as the Grand Canyon. Those layers of rocks were there. And those layers are there was Precambrian rocks, there's Paleozoic rocks, Mesozoic rocks, Cenozoic rocks. But these streams flowing over the Colorado Plateau started to cut down into it. And as the Colorado Plateau got uplifted, it made it a little bit easier for the streams to weather and erode down into it, thus creating the Grand Canyon. So here's the area of the Colorado Plateau. Just keep an eye on this area here. You'll kind of see it's kind of doming up here. Oops, right there, kind of doming up. So this is the Colorado Plateau. This area, again, here's Utah, Colorado, New Mexico, Arizona. So all of this got uplifted during that laramide orogeny. And just a little visual at how the Grand Canyon formed. Again, going back to the Precambrian, the original basement rocks of the shield and platform of the North American craton, that was weathered and eroded down. Sediment on top from the Paleozoic era, sediment turning into sedimentary layers, and that continued through the Paleozoic, Mesozoic, and Cenozoic. That material got weathered and eroded down. Uplift began to occur during the Cenozoic, as well as the Colorado River carving down into the layers, thus creating the Grand Canyon. So the Grand Canyon itself is only about 10 million years old. That's when the Colorado River began to kind of cut down through it. So that's about 10 million years old. Remember, the layers of rocks are hundreds of millions and even into the billions as you get down into the basement rocks. So when the rocks formed and when the canyon formed are two different things. For instance, the Rocky Mountains. The rocks that they were made of that got uplifted, the granites, are hundreds of millions, if not billions of years old. but the Rocky Mountains themselves weren't uplifted until 40, 50 million years ago. So when the mountains formed and the age of the rocks are two different things. Same with the Grand Canyon. The age of the rocks and when the canyon formed are two different things. All those sedimentary layers had to be there first before something cut down through it, forming the Grand Canyon. It's principle of cross-cutting, principle of lateral continuity. These had to be continuously sideways, laterally continuous layers. They don't just form on one side and the other side naturally. So the Grand Canyon, about 10 million years old. The layers that make it up, hundreds of millions, if not billions of years old. Let's go ahead and pause there. We'll talk about another famous geologic feature of North America that came to fruition during the Cenozoic, and that's the San Andreas Fault. See you back here in just a second.